Assalamualaikum and very good day to all the panels. In this video, we are going to present to you about our final year project which titled Corrosion Behavior of Copper Tincing as Substitution of Nickel. This group has consists of 2 members, including me. My name is Khalisah Assyazalin Binti Zulkifli, AA201096. I am the leader of this group, and my other member is Dina Nuraisya Hani Binti Arshad. Our project supervisor is Rozainita Binti Rosley. Let's start with project description. First, problem statement. This study will be a significant endeavor in surfacing several issues related to nickel products that have been arisen lately. This due to the continuous using of nickel in many industries for decorative objects, which may result in health-threatening cases, particularly skin conditions like skin allergies. Not only that, cyanide solution as an electrolyte in alloy production can also pollute the environment and affect human health. So in this picture, we can see there are several effects that can be happen to human and also environment if we use and also produce nickel. Therefore, the objective of this project is to carry out by preparing copper tincing via electroplating process. Second, to study the corrosion behavior of copper tincing prepared via electroplating. And lastly, to investigate the morphology of copper tincing produced via electroplating. This study is significant as the aim of this study is to substitute the usage of nickel in the copper tincing ternary alloy. There are various analyses have been conducted throughout this study, including surface morphology and composition analysis using scanning electron microscope (SEM) and energy dispersive X-ray (CeDS). The thickness of the electroplating layer, which is analyzed using field emission scanning electron microscopy (FESM), and lastly corrosion rate, which is measured by potentiostat, galvanostat, as well as the effect of additive on the production of copper tincing alloy. Next is methodology. This picture will represent the flowchart of our project, which starting by preparing the substrate and electrolyte first. The surface of substrate used need to be cleaned from any dust or dirt. This can be done by soak the substrate in acetone solution and 10% of sulfuric acid. Next is preparation of electrolyte. All of the solution need to be poured following the order, starting with copper chloride, zinc chloride, sodium hypophosphate, sodium formate, and lastly is tin chloride. Once the electrolyte is done, analyze the electrolyte using EIS to get the cyclic voltammogram. After that, set up all the material for electrodeposition process in order to achieve objective 1. Once it's done, test the corrosion behavior of each sample using EIS. This step will help to reach objective 3. Then, each sample will be analyzed using SEM for surface morphology and composition of copper tincing, and for SEM to see the thickness of addition of copper tincing on substrate surface. Here is the picture of each process, analysis, and method were used in order to complete this project.
Assalamualaikum and a very good day to all the panels. I'm Dina Nuraisya Hani Binti Arshad and my matrix number is AA200252. Now I'm going to proceed the presentation by explaining the findings obtained by our group throughout this project. The first one is we have analyzed both electrolyte with and without the addition of 5,5-dimethylhydrogen through cyclic voltammetry analysis. As a result, we found out that the complexing agents used in this experiment helps in lowering the reduction potential of copper, tin and zinc with the addition of 5,5-dimethylhydrogen as additive. As you can see in figure A, There is no curve observed without the addition of 5,5-dimethylhydrantoin, which indicates that the reduction happens, but it might be involving other elements besides copper tin zinc. In figure B, there is a presence of reduction peak, which indicates that the reduction of copper tin zinc is happening with the addition of 5,5-dimethylhydrantoin. Next, we have analyzed the effect of 5,5-dimethylhydrantoin on the production of copper tin zinc alloy. In figure A, the morphology shows most porosity, rough, less dense, and less compact, while the result in figure B shows a less porosity, smooth, dense, and compact surface. Therefore, it can be concluded that the presence of additives in electrolytes significantly influences the architecture of copper tin zinc deposited on carbon. Moving on to the result for corrosion test, from the TEFL plot, we can see that the curve of sample with additive is sharper compared to the curve of sample without additive. For your information, the current density and surface area applied is set to 23.365 gram per centimeter cube and 3.04 centimeter square respectively, while the equivalent weight for the sample without and with additive is 0.512 gram per mole and 1.8 gram per mole respectively. The corrosion rate of each sample is tabulated in the table, where the sample with the addition of 5,5-dimethylhydrantoin have a higher corrosion rate than the sample without 5,5-dimethylhydrantoin, which means it is more likely to wear down. This shows that 5,5-dimethylhydrantoin is not a suitable additive to lower the corrosion rate of copper tin zinc. Last but not least, the morphology of copper tin zinc coating after corrosion test as shown in figure A shows many holes, which indicates that it has a high corrosion rate, while in figure B, less hole and smooth surface is observed, which indicates a low corrosion rate. For the next part, I'm going to explain the novelty and inventiveness of this project. In terms of method, we have used sodium hypophosphate and sodium formate as complexing agent to lower the reduction potential of copper, tin, and zinc due to the large gap between each element. Other than that, we have applied a constant current for electroplating, which is 2 ampere, so that the result for each sample is comparable. One of the new findings obtained throughout this project is the current of 2 ampere produced the best coating. A current below 2 ampere produces a less adhesive, while current higher than 2 ampere makes the substrate combustible. The next finding is the various effect of 5,5-dimethylhydrantoin, which includes lowering the reduction potential of copper tin zinc, producing a great surface morphology as well as producing a high corrosion rate of copper tin zinc coating. Now, I'm going to share the potential application of this project. The first problem that we have faced is an uneven and less adhesive coating of copper tin zinc on substrate. This might happen due to the low current density applied. We found that 2 ampere produced the most adhesive coating. On the other hand, we changed the electrolyte after 2 times being used for electroplating because the composition of copper tin zinc in electrolyte might decrease after multiple use. The second problem is an unreadable graph of cyclic voltammogram and TEFL plot, which is caused by the precipitation of tin chloride in electrolyte. To fix that, we constantly stir the electrolyte throughout the analysis. Last but not least, we obtain a poor surface morphology of copper tin zinc. This might happen due to the uneven coating on the substrate. We have overcome this problem by analyzing only the fully coated parts on the substrate.
There are 3 potential developments. First is zinc adhering to the substrate surface is too little. To overcome this problem, the best development that can be used is by enhancing the amount of zinc content in the electrolyte, or choose the most suitable complexing agent to lower the reduction potential between copper, tin, and zinc. Second is uneven plating. The best development that can be done is by add additive in electrolyte like 5,5-DMH. And lastly is poor erosion resistant. The best way to solve this problem is by develop and find the most suitable additive to generate a good corrosion resistance. There are a lot of benefits that will be obtained to human and environment once copper-tenzing is replacing the use of nickel. Once it changes, human will not getting any dangerous disease such as allergies, cardiovascular, kidney disease, lung fibrosis, and nasal cancer. Not only that, this project also changed the use of cyanide solution into less hazardous electrolyte, where this can help humans to gain healthy food which is free from poisonous. And workers in industry, especially jewelry industry, can stay healthy as it allows the cells of the body from using oxygen. Moreover, this project will also save the environment as there are no more pollution and global warming occur. Humans can live healthily and peacefully, so there will not be a decline in habitat population.
As a conclusion, the morphology of copper-tenzing produced via electroplating shows a smooth surface when electroplated in electrolyte with additive. Other than that, we found out that the sample electroplated in electrolyte with additive have a higher corrosion rate. Therefore, it is believed that the findings of this study can be used as reference to improve the morphology of copper-tenzing, lowering the gap of copper-tenzing as well as increasing the thickness of copper-tenzing coating in the future study. The suitable additive to lower the corrosion rate, improving the addition of copper-tenzing coating as well as reducing zinc is recommended to be determined in the future study. That's all for the explanation of our group's project. I sincerely appreciate your attention throughout this video. Thank you so much for your interest and attention.